Hey, Calcers. So I'm going to go through the mini quiz from 423. It's a little bit of a review on Riemann. So first thing, we've got the rate at which water leaks from a container is modeled by the twice differentiable function R, and R is measured in gallons per hour, and T is measured in hours. So we want to use the data in the table to find an approximation for R prime of 1/2. So 1/2 falls between these two, 1/3 and 2/3. So when we think derivative, we think slope. So to approximate R prime of 1/2, we're going to find the slope. So it's approximately equal to 5 minus 8 over 2/3 minus 1/3. So we've got -3 over 1/3, and that's the same as multiplying by the reciprocal, so -9. And then we have gallons per hour divided by hour. That's going to be gallons per hour squared. All right, so the next one, I'm just going to erase this right here, and we're going to do the left Riemann sum with 3 subintervals from 0 to 1. So we're doing the whole entire chart from 0 to 1, 3 subintervals. So we break it into our 3 subintervals. So we've got the integral from 0 to 1 of R of t dt is going to equal approximately, the distance from 0 to 1/3 is 1/3, times, then we pick the one on the left because it's a left Riemann, so 11, plus the distance from 1/3 to 2/3 is 1/3, times the one on the left, 8, plus the distance from 2/3 to 1 is 1/3, times the one on the left, 5. And remember, this is Riemann, so that is my final answer. I don't have to simplify that. My units of measure are going to be gallons per hour times hours, so it's gallons. Okay, so that'll give me my total gallons over the course of 1 hour, okay, that leaked out of the container. All right, for letter C, we don't have R prime, the data for R prime, so we can't do like a Riemann sum or anything like that. But what we can do is we have the integral of R prime, so we can find the antiderivative of R prime, which is R of t. And then we evaluate that from 0 to 1/3. So we plug in 1/3, so R of 1/3 minus, plug in my lower bound, R of 0. So we plug in 8 minus 11, so that equals -3. Final answer. All right, last one. Is there a time from 1/3 to 2/3 such that R prime is equal to -9? So here's the deal. When we see, is there something such that we're thinking my theorems, because it's the derivative, it's going to be asking about my MVT. So in order to prove the MVT, we have to show that the slope connecting the two endpoints is going to equal -9. So R of 2/3 minus R of 1/3 all over 2/3 minus 1/3 has to equal -9. And it does, because we actually did that up here in A. So we know that it does equal A. Therefore, yes, there is a time. Such that R prime of t is going to equal -9. I proved by showing my slope over here because of the MVT. Okay, and that was proving showing my MBT over there. All right, guys, that's it for this one.